Composition of atmosphere. The atmosphere contains many gases, most in small amounts including some pollutants and greenhouse gases. The most abundant gas in the atmosphere is nitrogen, with oxygen second. Argon, an inert gas, is the third most abundant gas in the atmosphere. The atmosphere is concentrated at the Earth's surface and rapidly thins as you move upward, blending with space at roughly 100 miles above sea level. The atmosphere is actually very thin compared to the size of the Earth, equivalent in thickness to a piece of paper laid over a beach ball. However, it is responsible for keeping our Earth habitable and for producing weather. Nitrogen accounts for 78% of the atmosphere, oxygen 21%, and argon 0.9%. Gases like carbon dioxide, nitrous oxides, methane, and ozone are trace gases that account for about a tenth of 1% of the atmosphere.
Air pollution refers to the release of pollutants into the air that are detrimental to human health and the planet as a whole. In an even broader sense, air pollution means the presence of chemicals or compounds in the air which are usually not present and which lower the quality of the air or cause detrimental changes to the quality of life. In most cases, air pollutants cannot be seen or smelled. However, that does not mean that they do not exist in high enough amounts to be a health hazard. Additionally, a number of gases are linked to the so-called greenhouse effect, which means that those gases retain more heat and thus contribute to the overall global warming. The most common example of a greenhouse gas is carbon dioxide, which is emitted from many industrial processes. Another example is methane, which is also an explosive gas. Air pollution has serious effects on the human health, depending on the level of exposure and the type of pollutant inhaled. These effects can vary, ranging from simple symptoms like coughing and the irritation of the respiratory tract to acute conditions like asthma and chronic lung disease.
What is global warming? Glaciers are melting, sea levels are rising, cloud forests are dying, and wildlife is scrambling to keep pace. It's becoming clear that humans have caused most of the past century's warming by releasing heat-trapping gases as we power our modern lives. Called greenhouse gases, their levels are higher now than in the last 650,000 years. We call the result global warming, but it is causing a set of changes to the Earth's climate or long-term weather patterns that varies from place to place. As the Earth spins each day, the new heat swirls with it, picking up moisture over the oceans, rising here, settling there. It's changing the rhythms of climate that all living things have come to rely upon us. Impact of greenhouse gases on global warming. The greenhouse effect is the warming of climate that results when the atmosphere traps heat radiating from Earth toward space. Certain gases in the atmosphere resemble glass in a greenhouse, allowing sunlight to pass into the greenhouse, but blocking Earth's heat from escaping into space. The gases that contribute to the greenhouse effect include water vapor, carbon dioxide, methane, nitrous oxides, and chlorofluorocarbons. On Earth, human activities are changing the natural greenhouse. Over the last century, the burning of fossil fuels like coal and oil has increased the concentration of atmospheric carbon dioxide. This happens because the coal or oil burning process combines carbon with oxygen in the air to make carbon dioxide. To a lesser extent, the clearing of land for agriculture, industry, and other human activities have increased the concentration of other greenhouse gases like methane and further increased carbon dioxide. The consequences of changing the natural atmospheric greenhouse are difficult to predict, but certain effects seem likely. On average, Earth will become warmer, Some regions may welcome warmer temperatures, but others may not. Warmer conditions will probably lead to more evaporation and precipitation overall, but individual regions will vary, some becoming wetter and others drier. A stronger greenhouse effect will probably warm the oceans and partially melt glaciers and other ice, increasing sea level. Ocean water will also expand if it warms, contributing to further sea level rise. Meanwhile, some crops and other plants may respond favorably to increased atmospheric carbon dioxide, growing more vigorously and using water more efficiently. At the same time, higher temperatures and shifting climate patterns may change the areas where crops grow best and affect the makeup of natural plant communities.
Water. Water is a transparent, tasteless, odorless, and nearly colorless chemical substance which is the main constituent of Earth's streams, lakes, and oceans, and the fluids of most living organisms. It is vital for all known forms of life, even though it provides no calories or organic nutrients. Water is one of the key reasons for human survival and civilization in general. Water is considered to be the most important factor behind existence of life on Earth. Types of water. Water is distinguished on the basis of its origin, consistency, composition, and treatment. Number 1. Tap water. Tap water is the water that you get directly from your faucet. It may or may not be suited for drinking purposes. It is widely used for household chores such as cleaning, cooking, gardening, and washing clothes. It must meet the regulations set by the local municipal bodies. Number 2. Mineral water. Mineral water is the water that naturally contains minerals. It is obtained from underground sources, which makes it rich in mineral, like calcium, magnesium, and manganese. No further minerals can be added to the water. The water also cannot be subjected to any treatment, except for limited ones such as carbonation, iron or manganese removal before packaging. The essential minerals give it a reputation of healthy drinking water. The presence of the minerals also gives the water a characteristic salty taste. Number 3. Spring water. In some places, rainwater accumulated underground tends to leak out at the surface as a spring or puddle. Natural springs are not passed through a community water system and are yet considered suitable for drinking as it comes from under the ground. Number 4. Well water. When it rains, water trickles down and travels through the inner crevices of the soil beneath the ground to form underground lakes. This happens over a period of time. In rural areas, one of the primary sources of water is what is dug out from deep wells. Number 5. Purified water. A purified water is the water which after deriving from its source has underwent purification treatment in a plant. The act of purifying entails removing all bacteria, contaminants, and dissolved solids, making it suitable drinking and other purposes. Enough pure water to consume. Number 6. Distilled water. Distilled water or demineralized water is one where the water has been subjected to a treatment that removes all its minerals and salt by the process of reverse osmosis and distillation. It is an absolutely pure form of water, but it is not typically recommended for drinking. Number 7. Sparkling water. You may have encountered waiters in your favorite restaurant asking your preference of water, regular, mineral, or sparkling. Sparkling water is the water that has undergone carbonation, which makes your water fizzy just like your sodas. Sparkling water may be spring water, purified water, or even mineral water. Upon addition of carbon dioxide, it becomes sparkling water.
Artesian water. Yes, this water is special. It is not simply from an underground spring, but this title of Artesian contains specific parameters about how deeply set the water source is. In short, artesian water, in theory, has the chance of being more pure than basic spring water, since it comes from a deeper source and has to travel through deeper levels of natural filtering through Earth.
Water quality standards consist of four basic elements. First, designated uses of the water body. Second, water quality criteria to protect designated uses by limiting chemical constituents that may be present in the water body. Third, an anti-degradation policy to maintain and protect existing uses and high-quality waters. Fourth, general policies addressing implementation issues.
Clean, safe water is vital for everyday life. Water is essential for health, hygiene, and the productivity of our community. The water treatment process may vary slightly at different locations depending on the technology of the plant and the water. Coagulation. During coagulation, liquid aluminum sulfate or polymer is added to untreated water. When mixed with the water, this causes the tiny particles of dirt in the water to stick together or coagulate. Next, groups of dirt particles stick together to form larger, heavier particles called flocks, which are easier to remove by setting or filtration. Clarification. As the water and the flock particles progress through the treatment process, they move into sedimentation basins where the water moves slowly, causing the heavy flock particles to settle to the bottom. Flock which collects on the bottom of the basin is called sludge and is piped by drying lagoons. In direct filtration, the sedimentation step is not included, and the flock is removed by filtration only. Filtration. Water flows through a filter designed to remove particles in the water. The filters are made of layers of sand and gravel, and in some cases, crushed anthracite. Filtration collects the suspended impurities in water and enhances the effectiveness in disinfection. The filters are routinely cleaned by backwashing. Disinfection. Water is disinfected before it enters the distribution system to ensure that any disease-causing bacteria, viruses, and parasites are destroyed. Chlorine is used because it is a very effective disinfectant, and residual concentrations may be maintained to guard against possible biological contamination. Disinfection. Water is disinfected before it enters the distribution system to ensure that any disease-causing bacteria, viruses, and parasites are destroyed. Chlorine is used because it is a very effective disinfectant, and residual concentrations may be maintained to guard against possible biological contamination in the water distribution system.